So from a histological point of view, we can see two types of bone tissue. The first type is called fibrillar bone or woven bone, and because it occurs as a first type during ontogenesis, it's called also primary bone. The microscopic organization does not show any preferential direction. So the some osteocytes run like this with their processes. Some osteocytes are oriented elsewhere, and there is no apparent prevailing direction in that. So they are touching with the network of their cell processes, and this lack of orientation is reflected also by the various directions of the type 1 collagen that makes the extracellular matrix, and also the mineral crystals that adhere on the surface of the collagen. They are organized in various directions. We have the blood vessels here in bone. So these are the osteocytes. And the collagen fibers run in many directions. However, although this type of bone tissue appears as the first one during embryogenesis, during the fetal ossification, it very soon undergoes remodeling into the lamellar or version or secondary bone. The only parts of bone in human body that retain this structure of the primary bone are the tuberosities, like on the tibia, the calcaneus or chin. Most of the other skeleton, like 98-99%, remodel into the secondary bone, which is much more organized. There is usually a vascular canal containing blood vessels, so I'm adding an arteriole and a venule, and this vascular canal is surrounded by lamellae of the bone matrix, which includes collagen and the amorphous matrix and the crystals. Then you have the bone cells, so the osteocytes, which are arranged in a concentric manner that surrounds this central vascular canal. And you have more of these concentric layers of osteocytes. Okay. And among these osteocyte layers you have lamellae of bone matrix. So there are preferential orientations here. we have the central vascular or Haversian canal with blood vessels. We have the concentric layers of osteocytes. Another layer, and we have the concentric layers of bone matrix, also known as the bone lamellar. And I gave the name to the whole type of bone. These systems are called osteons, so this is an example of an osteon or Haversian system. The distribution of the bone in the human body favors the lamellar bone because this bone has a great adaptation capability. It's oriented so it much more better reflects the loading of the bone, where the major mechanical resistance could be much better organized to resist the forces loading the bone. The fibrillar bone cannot do that because it has similar structure and similar properties in many directions.